So I see that this is a product under a fifth root. So then I have the fifth root of negative 243 times the fifth root of x to the fifth times the fifth root of y to the 15th. I know that there is no need for the absolute value. It says all positive anyway, but it's the fifth root, so I know that this will be x, and I know that this will be y to the third. And I've noticed that you came up with here what? With negative 3 to the fifth power, right? That's fine. You cannot change negative 3 into 3. It says variables, not numbers. Is that okay? So then the answer is obviously negative 3xy to the third. Do we all agree with this? Yes? Okay. Then I'm so happy to see that almost everyone wrote the condition correctly to find the domain. What is the condition for this function to find the domain? What do I have to write? Plus 4. Exactly, which means x greater or equal to negative 4. So the domain of this function is negative 4 to infinity. You cannot start at any other point, but you have to start at negative 4. So then if you use a chart, which I recommend, you have to write a negative 4 to infinity as we did it together. You plug in negative 4, you get 0. And then you should determine two other points. So with 0, 0 plus 4 is 4, the square root of 4 is 2. And then let's say, what? Okay, because the square root of 9, which is 3. So you have to have 3 ordered pairs. You have to start at negative 4, 0. You cannot start at any other point. And then 0, comma 2, and then 5, comma 3. And that's the graph of the square root of x plus 4, and that's our f of x. I did not ask for the range. I forgot. But the range is clearly 0 to infinity. I will not deduct points, of course. I didn't ask for this. Okay, very good. That's my first page here. Good. Now I would like to go back and look at a couple of problems with taking square roots from both sides. It's a principle that is very important in many, many cases. And then we go back to the book and finish up 10.3 and move on to 10.4, and then go back to the handout and so on and so forth. So first, I would like to practice something like x minus 2 squared minus 4 equals 0. What type of equation is this? If you expand this, you'll get x squared. So obviously, it's a quadratic equation. Okay. How do I solve it? No, I don't want to expand. I'm not saying that you said that, but I would not expand x minus 2 squared into how many terms? We have an agreement on this. X minus 2 squared has how many terms?
3.
Not 2, but 3. So let's look at the agreement when you can. So I will move 4 to the other side. And now I will apply this taking square root procedure, taking square roots from both sides. What should the left answer be? X can be any real number. I don't have any indication of, I'm not told anything specifically about x, so I have to assume that it's all real numbers. So what should the answer on the left-hand side be? Say it again. Right. Yes. X minus 2 in absolute value, and that's 2. And then we have two options. One option is x minus 2 could be, because it's quadratic, we expect two solutions. X minus 2 could be 2, or x minus 2 could be negative 2. So from here I have x equals 4, and from here I have x equals 0. So however, we skip this step normally. when we take the square root. Okay. The reason on the first few examples I will not skip it is because if I do skip it, and directly I go here and I write x minus 2 equals plus or minus 2, you may be tempted to think that the square root of 4 is plus or minus 2. That would be false. The plus or minus come from this side. From solving the absolute value equation, I get the plus or minus. Not because the square root of 4 is 2. So do not get confused on that. I saw it in many, many papers. Students write, oh, the square root of 4 is plus or minus 2. No. Because they skipped this step from the very beginning and they said, oh, we don't think in these terms all the time, right? But the answer here is the absolute value, and the absolute value creates the positive and the negative 2, not the right-hand side. So one more time, the two symbols come from the left-hand side, not from the right. So I crossed it out because I'm not going to write it again. But I want you to remember there is an intermediate step in there. And then from here, I add 2. I will get exactly the same answers. The 2 plus 2, which will be a 4, and the 2 minus 2, which will be a 0. So keep in mind, every time we take square roots from both sides, there is an intermediate step in there. We became lazy and we don't write it anymore. But not to be assumed that the square root of 4 is plus or minus 2. Okay? So let's look at one more example. Let's say negative 2, x plus 3 squared. Minus 6, let's say plus 6 equals negative 12. So I'm asked to solve this equation. And you can say, wait a minute, you're talking about radicals and now we jump to quadratic equations. True. Because I need now, since this is our first exposure to taking square roots from both sides, I would like to cement it. I will do it again when time comes in chapter 9. Not 9, 10. Not 10, 11, sorry. But I need it now. So what would you recommend? No, we're not going to expand x plus 3. What would you recommend? And the answer is you must clean it up first. How do I clean this up? Remember, simplify factor. Simplify factor are the key words. So how will I clean this up? Of course. Very good. So I have negative 2 x plus 3 squared equals negative 18, obviously. After that, I still have one more step to clean it up. Exactly. I have to divide by negative 2. So I have x plus 3 squared equals 9. Now I can apply the principle of taking square roots. And I will do it. I know it's quadratic and I know I will have to get 2 solutions. I will skip the intermediate step now, but I cannot forget to write what on the other side. Exactly. Not to be understood that the right-hand side says that the square root of 9 is plus or minus 3. To be understood that this should have been the absolute value. That's where the 2 symbols come from. And now I move 3. So I have x equals negative 3 plus or minus 3. I will have to separate the solutions into negative 3 plus 3, which is 0, and negative 3 minus 3, which is negative 6. Any questions? Any questions? I think now we can go back. Let's choose 2 other ordered pairs to determine this time the distance, but also the midpoint. So what is the midpoint? Let's suppose we have this line segment between A and B. Of course, x1 comma y1 and x2 comma y2. And this point right here, it's called the midpoint because it bisects the segment. obviously, or divided into two equal parts. The coordinates of the midpoint will always be the average of x's, which means x1 plus x2 divided by 2, and the average of y's, y1 plus y2 divided by 2. This is what I did not get the chance to tell you last time. So we're going to pick two ordered pairs. If you want to pick the ones that I selected here on the handout, fine. If you don't, that's fine too. Make up two other ordered pairs. And let's determine the distance and also the midpoint. So we can consider 10.3 done and move on. So please give me two ordered pairs. Six and 4. And also one of them should be negative so we can see how that works. Doesn't matter. 7. Very good. I have to write a distance formula, which can never be simplified. x2 minus x1 squared plus y2 minus y1 squared. I know the quantity under the square root will be positive because there are two squares added together. I will consider my x1, y1, and my x2, y2, and I will put them in accordingly. So this is -2, and this is 6, and this is 7, and this is 4. So in the first parenthesis, I have -2 minus 6. How much is -2 minus 6? 4. Careful. I beg you for $2, and then I beg for 6 more. How much do I owe you now? 8. How much is -8 squared? 64 indeed. Plus. How much is 7 minus 4? How much is 3 squared? 9. So then the distance is the square root of 73. 73 is 73. I cannot simplify. Of course, if you'd like to find an approximation, you can. Grab your calculators and you put the square root of 73, and you can approximate it to 8.54. Now I would like to determine the point that will divide the segment into two equal parts. All I have to do is add the x values. When I add 6 to -2, what do I get? 4. How much is 4 divided by 2? 2. That's the x coordinate of the midpoint. Now I'm going to add 4 to 7. How much do I get? 11. So then the y coordinate is 11 divided by 2. And that is the end of section 10.3. Any questions? Any questions? Okay. I'd like to come back to my handout for a minute. We learned this. Let's read it one more time. Radical expressions are fully simplified if there are no negative exponents in the final answer. The exponents under the radicals are numbers smaller than the index. And there are no radicals in the denominators. Now, this is part of section 10.4. Let's read it, but I'm going to go slowly back to the book before we look at this problem. Adding and subtracting radical expressions. Like radicals are those radicals with same index, same variables raised to the same powers. Norville, do you have this handout? Okay, I forgot if you were here when I gave it out. Same variables raised to the same powers. Variables are placed in the same position in the radical expression. If they are outside or inside the radicals, they all have to have the same thing. Only like radicals can be added or subtracted. So let me give you a couple of examples. with like radicals and unlike radicals, and you'll tell me which ones can be added or subtracted. For example, xy the square root of 2x and x squared y the square root of 2x. Are these two like radicals? No. They do have the same radical in the sense that it's the same index, the same radicand. They do have the same variables outside, but the variables don't have the same power. So these two radicals cannot be added or subtracted. Here's another example. Negative 3x squared y cubed, the square root of 7x, with 6x squared y cubed, the square root of 7x. Are these radicals that are like radicals? Can they be added or subtracted?
Yes.
Yes, because they have the same radical part, the same radicand, the same index. They have the same variables outside with the same powers, and I don't care about the number in front. I can say negative 3 apples plus 6 apples, or I can say negative 3 apples minus 6 apples, and I will be able to combine them. So these are not like radicals, these are like radicals. So that's what we are going to do in section 10.4. So I'm going back to the book. If you have your book, please choose. If not, you will trust me to choose. Trust me to choose, and I will. Okay, thank you for the vote of confidence. Let's say 9. The square root of 9b cubed minus the square root of 25b cubed plus the square root of 49b cubed. Here's my first question to you. Are these like radicals? The radicand has to be absolutely identical. I cannot add anything inside. So the indices are the same, but this portion is not the same. This is not identical with this, and is not identical with this. So they are not like radicals. Will I eventually be able to add or subtract them? Maybe. I don't know yet. Till I do what to each and every one of them? Fully simplify. That's why we read this part. First of all, the exponents under the radicals have to be smaller than the index. Then if I have a number, maybe I should put that, I'm constantly updating my handouts. Maybe I should put that in also about the number. The number has to be simplified, whatever. I didn't put it in. Okay, so then I notice that each and every one of them is a product. I'm going to split them then. The square root of 9, the square root of b cubed. But what do I do with b cubed knowing that the index is 2? How do I split b cubed? Exactly. B squared and the square root of b. Can anyone dictate the second radical, and you only have to do what I just did with the first one, or to the first one? Very good. Plus the last one, the square root of, and the square root of, and the square root of b. Good. Now, can anyone give us the fully simplified form of the very first radical? We are assuming everything is positive. I should have read this. They're not saying it. We are assuming now everything is positive. The target is different. So, can anyone give us this fully simplified form of the first radical? Can anyone give us the fully simplified form of the second radical? Perfect, thank you.
5b squared root of b.
Excellent. And the last one?
7b squared root of b.
Now here's my question again. Are these like radicals? Can I say 3 apples minus 5 apples plus 7 apples. Good, so then the final simplified form is b the square root of b. Everything is simplified, radicals are simplified, the index is bigger than the power here, or the power is lower than the index, whatever you want to say. So everything is correct, simplified. Good. Now we can work on the problem from the handout. Problem from the handout looks awful. It's not. Just looks. It's more work. Okay. Let's see. I don't like any of them. I do like the 8 to the 4th. That's the only one, and the 8 to the 4th here. Of course, assume everything is positive for now. As I said, the target is totally different. So what do? I have to take each and every radical separately in a way and work on it, right? Okay. So now remember, this dictates. That's a dictator right now. Number 4, index 4. Okay, so I have 2a. So let's think in terms of the 4th root. What should I do with 32? Is there a perfect 4th? 32, a perfect 4th times something that will give us 32. 8 is a perfect cube. You need one more. 16, indeed, I agree. So I have the 4th root of 16 times the 4th root of 2. Now what do I do with b to the 5th? Because 5 is greater than 4. So that's not fully simplified. So that is the 4th root of very good, times the 4th root of the remainder, which is b, minus, I got to the second radical. I have no idea what 162 is. So I'm going to do a side calculation for 162. I know it's divisible by 2. It's an even number. And then I get 81. So now I know what I need. What do I need? How do I split 162? The 4th root of which one? 81, which will be 3, right? 4th root of 81. 3 to the 4th power is 81. Times the 4th root of 2 times the 4th root of a to the 4th times the 4th root of b. Do we all understand and agree with the second radical? Becky, go ahead. Which one? Yes, that's why we have to split it. That's why we have to split it into 2 and 81. Because the 4th root of 162 is not an individual. But the 4th root of 81 would be 3. And we have to keep the 4th root of 2 as is. Yes, please.
Would we have to have an extra 4th root of b? Because the last one is the 4th root of 2a to the 4th.
You mean this one?
Yes.
Okay, you're way ahead of me. So let's work on the last one. You'll see in a minute. So then I have the 4th root of 2. I have the 4th root of a to the 4th. Now what do I do with the 4th root of b to the 5th? Yes, into the 4th root of b to the, yes? And the remainder, the 4th root of b. Did I answer your question?
Yes.
Okay, perfect. Now we're going to simplify each and every one of them. Please tell me what is the simplified, or give me the simplified form of the first radical. And careful. What is this? The fourth root of 16. Which number I raised to the fourth power to get 16? 2. But I have to multiply it by 2 in front. So this will be 4. It will be A. Now from here, this comes out. What is it? Right? And now these two have to stay under the radical. There is nothing I can do to the fourth root of 2. There is nothing I can do to the fourth root of b. So this must be the fourth root of 2b. Can anyone give us the simplified form of the second radical? It's minus. Minus what?
27.
So what happens here? What is this? But it has to be multiplied by the 3 in front. Negative 9. Very good. So I have negative 9. Then this has to come out. So it's negative 9a. There is a b in front, which I cannot forget about. And there are two pieces that have to go back to under a radical. So this is the fourth root of 2b. Do we agree with the second one? The simplified form of the second one. Okay, can anyone give us the third one, which is plus? This will come out, and this will come out, but these two have to stay.
Or AB.
Just two, just AB. AB. There is no number in front, it's just 1. And then the fourth root of 2b. After all this work, look at those 3 radicals and say yay or nay. Are they like radicals or not? Yes, because they have the exact same radical, the fourth root of 2b, all of them. They have the exact same variables in front, and both variables in front have the same power. So now this is like saying 4 minus 9 plus 1. How much is 4 minus 9 plus 1? Negative 4. And what else? Yes? And times the fourth root of 2b. Any questions? It was a lot of work on this one. I think we should choose one more. Would you agree? Okay, so let's say 33 on page 616. 33 on 616. I have to be honest with you. You are not going to see this a lot in the next courses. It's just a little bit of an exercise of how to simplify radicals, but you're not going to see applications of this later. Okay? So we just need to know how to work with these radicals, but beyond that, it's not super important. Rationalizing denominator is super important. That is used everywhere. Taking square roots from both sides of an equation, super important, used everywhere when it's applicable. But something like this is not. Multiplying radicals, multiplying expressions with radicals, yes, but this is not a highly important topic. But let's do one more problem. Okay, so 33. Negative 2, the fourth root of x to the 7th, plus 3, the fourth root of 16, x to the 7th, and minus x times the fourth root of x to the 3rd. So let's work on this problem for 1 minute. So negative 2, the fourth root of x to the 7th, plus 3, the fourth root of 16x to the 7th, minus x, the fourth root of x to the 3rd. First question I have here, are they like radicals? Will they be like radicals? I don't know. I'm hoping that they both, all three simplify to the same thing. Same irrational part, but we don't know until we work on each and every one of them. So give it a shot, and then we'll work on it together. So you may see something like this, but not with so many variables and not so involved or involving. Do we need more time? Okay, so I'm looking at the first one. Again, 4 dictates. I have 7. What do I do with that? Plus 3. Then I have the fourth root of 16. And since it's the same thing, I'm going to copy it again. And the last one, can I simplify the last one in any way, shape, or form? No, because the power is less than the index. Good. Now, the only thing that I can simplify here is this. So then I have negative 2x, the fourth root of x to the 3rd. Agreed? Now I know that the fourth root of 16 is 2, but I have to multiply it by 3 in front. So it will be plus 6, and then this one is x, the fourth root of x to the 3rd, minus x, the fourth root of x to the 3rd. Now I look again, and I realize that they have the exact same radical, identical. They have the same variable in front with the same power. So now I will only say negative 2 plus 6 minus 1, which results into 3x, the fourth root of x to the 3rd. So this is okay, but multiplying is more important. So now we have a bunch of problems. I'm looking at problems from 47 through 76. This is more important on page 616. So let's choose from there. I'll choose a couple and then you will work on a couple. I'm gonna choose 48 first. Yes, this part is useful. More useful, I would say. Well, normally the grouping symbol tells us perform this operation and then multiply. But there is nothing I can do here. I cannot simplify the square root of 15. It's 3 and 5, 3 and 7. There's nothing I can do. I can never add these two. They're not like radicals, and they cannot be simplified. So my only chance to simplify is to remove the parentheses by distributing. So when I distribute, I know I will have to write the square root of 5 times the square root of 15. I want to write the intermediate step. And minus the square root of 5 times the square root of 35. That is clear for now. I'd rather not multiply, because if I multiply, I get 75, and then I have to go back and factor. So I can simplify. I would rather not multiply, because when I do, I get 175, and I don't want to do that. I notice that there is a 5 in here and a 3. So I will know that this is nothing else but 5, the square root of 3. I know there is a 5 and a 7 here. And this must be 5, the square root of 7. But yes, no one can simplify this, because they are not like radicals. If you want, you could factor out 5. There is no need at this point, but you could. But I'm fine with this. So I like to practice this idea. For example, 52. Before we look at 52, let me know if you have any questions. Let's go back and think about this one more time. So I could not combine these two. So the only chance I had was to distribute the square root of 5. Yes, I can multiply them because they have the same index. However, I realize that there is a 5, and a 3. So it will be the square root of 5 times the square root of 5 times the square root of 3. But the square root of 5 times the square root of 5 will be 5. And then the square root of 3 stays. Minus. I have the square root of 5 times the square root of 5 times the square root of 7. But the square root of 5 times the square root of 5 will be 5. And then the square root of 7 has to stay. So now let's repeat the process on this one. Tell me, what would you tell me to write? What would you write yourself? And I'll write it too. What would you write? Again, can you combine these two? We cannot combine them. The square root of y and the square root of 5 are not like radicals. So what I have to do is, again, distribute. But I would like to distribute wisely. Or you can write it in several steps. You don't have to do it in one step. So I will have the square root of 5 times the square root of y times the square root of y. And then plus the square root of 5 times the square root of y times the square root of 5. Assume all variables are positive here. What do I do? What is the first radical simplified form? How does it look? Exactly. How does the second radical look like, simplified? Yes. Now I'm asking again, can we combine these? Absolutely not. They don't have the same radical. They don't even have the same variable in front. There is nothing we can do here. How do you feel about this? Do we need another example of this kind, or can I move on to the next level? Okay. Well, we can go back anytime. So 54. Let's see how we multiply 8 the square root of y plus z times 4 the square root of y minus 1. This is important. These are all important because they will be used in rationalizing. I can't get away from this, even if I wanted to. So notice the difference. In the previous example, we had a sort of a binomial, 2 terms, and then 1 term in front. What is different now? Well, I have 2 terms. What is my only chance to eliminate parentheses? Yes, FOIL, right? This distributed to these 2, and this distributed to these 2. Remember, what is outside multiplies the outside. what is inside multiplies the inside, the radical, right? So when I distribute here, I have to multiply the outsides first. 8 times 4, 32. And now I multiply the insides. Now I multiply the square root of y by the square root of y. And before we do that any further, I would like to establish something very important. So that's a note before we continue the problem. Here's my note. How much is the square root of 2 times the square root of 2? Well, the same radical. It's the square root of 4, which is 2. I would like from now on to skip the middle step. And I'm going to ask you the square root of y times the square root of y is the square root of 3 times the square root of 3 is the cube root of 2 times the cube root of 2 times the cube root of 2 is, yes. So when I come back here and we said 8 times 4 is 32, now I'm at the stage in which I multiply the square root of y by the square root of y, and the answer is yes. Now I have to distribute this term to -1, no problem, minus 8 the square root of y. I finally got to the second term, but the second term doesn't have a radical. So I cannot multiply anything by the radical in here, but I have to multiply the two outside. All I have to write is 4z, the square root of y, and then distribute to -1 as negative z. This is useful. Let's look at 61. I would like you to work on it for a minute. So 2 the square root of 7 plus 3 the square root of 5. Quantity, the square root of 7 minus 2 the square root of 5. And tell me what you get. If you need help, raise your hand. I'll come and help you.